This is Algebra 1, Lesson 11.8, Multiplying and Dividing Radical Expressions. So let's start with our warm-up. Here we go. Okay, so again, when we look at 72, we want to figure out what's the biggest perfect square that can go into 72, and that is 36, and it goes in 2 times, so we can simplify this to 6 radical 2. For x to the 5th, the most groups of 2 that we can pull out are 2, groups of 2, with a single radical x left. For this 24, we can simplify it to radical 4 times radical 6 over radical 9. So then that becomes 2 radical 6 over 3. For my 18, I can simplify that to radical 9 radical 2, and then over x squared. So then I get 3 radical 2 over x. So we're going to look at multiplying and dividing radicals today. In the last lesson, it was subtracting and adding. So we need to know how to do something called rationalizing the denominator. So you're going to hear that. Okay, you can use the product and quotient properties of square roots, which we have already learned, to multiply and divide expressions containing square roots. So if I have 2 radicals multiplied together, what you're doing is you're taking what's underneath and multiplying them together. So 6 times 8 becomes 48, which then I would simplify to radical 16 radical 3, and then I could get 4 radical 3. If you wanted to, you could simplify the 8 first and then multiply what's left together. It's faster, I would say, to just multiply them first and then simplify. Okay, so in this next one, it's saying to take 2 radical 5 squared. So that means 2 radical 5 times 2 radical 5. So we're going to multiply what's in front. So 2 times 2 is 4. And then what you're doing is you're taking what's under the square roots multiplied. So 5 times 5 is 25, which simplifies to 4 times 5, and you get 20. Now, something I want you guys to know here is that if you multiply a radical by the same radical, for example, radical 5 times radical 5, that is equal to, it actually gets rid of the radical sign, and we just get what's underneath. So the way that works is because if you looked here, that becomes 25 underneath, and the square root of 25 is 5. If I did the square root of 7 times the square root of 7, that would be the square root of 49, which equals 7. So again, when you multiply a square root by itself, you just get what's underneath. So that's a really important rule to keep in mind. Okay, so I'm going to multiply this out first. So the 3 times the 12 becomes 36. Sorry, there's my radical sign. I know it looks a little strange. 36, and then my y times the y is y squared. So then that simplifies to 6y, because the square root of 36 is 6, the square root of y squared is y. Okay, in this one, we're going to distribute this radical 3. So when I take radical 3 times the 7, I get 7 radical 3. And then when I take it times this, I get minus radical 24. I want to simplify that radical 24, so I'm going to make it 4 radical 6, which becomes 7 radical 3 minus 2 radical 6. And I can't combine those since they're not like radicals, so you're just going to leave them as they are. Okay? If I'm going too fast, you guys go ahead and pause and go back and watch how I do a problem. All right, so in this next one, we're also going to distribute. So I'm going to get radical 16 because I'm multiplying what's under the radical. If it's out in front, like let's say it was 5 times, like we did in the last one, radical 2 minus 3. When you multiply it, it just gets put in front of it, okay? So just be careful. But if it's 2 radicals multiplied together, I multiply what's underneath, okay? So then when I multiply by this one, I get the square root of 36. So the square root of 16 is 4, plus the square root of 36 is 6, so my answer is 10. This was just an example over on the side. In Chapter 7, we learned to multiply binomials by using the FOIL method. So remember, FOIL means first, outer. This is not how you spell outer. Obviously, this is why I went into math. Inner and last. So we're going to always multiply in that order. And the same method is true. You can use the same property for multiplying square root expressions that have two terms. So let me show you an example. So if we had 4 plus radical 3 times 5 plus radical 3, your first term would be, you would do the 4 times the 5. Then you would do your outer. So that would be your 4 times the radical 3. Then you would do your your I, your inside. So radical 3 times 5 would be 5 radical 3. And then your last would be radical 3 times radical 3 right here. So this simplifies to 20. These will combine to make 9 radical 3. And then radical 3 times radical 3, remember I told you it just becomes what's underneath when it's the same thing. And then we can combine this 20 and this 3 to get 23. And then we have just the 9 radical 3 left. So let's try an example, okay? So I'm going to do my first. So 3 times 2 is 6. Then my outer, which is 3 plus 3 radical 8. Then my inner, so I have minus 2 radical 8. And then my last, which becomes a minus radical 8 times radical 8 will just be 8. I can combine this and this, so 6 minus 8 is negative 2. When I combine these, I just get plus 1 radical 8, so you can write it like this, or you can put the 1 in front, however you want. And that's all. Actually, though, we need to simplify this 8, so even though I said we were done, we're not. So we need to take negative 2 plus, this becomes radical 4 times radical 2. So I get negative 2 plus 2 radical 2. So just remember, you always want your answer to be in the most simplified form, okay? Because this 8 wasn't technically simplified. All right, let's try another one. So if I have 4 plus radical 3 squared, that means I'm taking 4 plus radical 3 times 4 plus radical 3, okay? And then I'm going to distribute. So 4 times 4 is 16. 4 times radical 3 is 4 radical 3. 4 times radical 3 is 4 radical 3. And then radical 3 times radical 3 is 3. So when I combine these, I'm going to get 19 plus, I've got to combine these, 8 radical 3. Okay? If you don't want to watch the day 2 part right now, you can go ahead and pause this video. If you want to just finish it up, it's not going to take very long, so you might just want to finish it up right now. Okay? So we're going to start the day 2 of 11.8 notes now. Okay, so we're going to do some practice with the stuff that we did in the 11.8 day 1. So we're going to multiply these radicals together. So when I do radical 5 times radical 10, I get radical 50, which simplifies to radical 25 times radical 2. So that simplifies to 5 radical 2. When I have this one, I need to distribute, so I'm going to get radical 14 plus, when I have the same thing times itself, it just becomes what's underneath, so plus radical 2. When I take 3, so I'm going to write this out, 3 radical 6 times 3 radical 6, I get this times this is my 9, and then these multiplied together become 6, so when I carry that out, I get 54. On this next one, I'm going to FOIL. So 6 times 2 is 12, minus 6 radical 3, plus 2 radical 3, minus 3. So when I combine everything, my final answer is 9 minus 4 radical 3. Okay, I kind of went out of order. I apologize for that. So if I take 6x minus 8x, that's going to give me 3 radical 48x squared. I can break that up into 3 radical 16x squared and radical 3. So then I'll have 3 times 4x squared radical 3, which is 12x squared radical 3. X, not x squared. Sorry. Sometimes I get ahead of myself. Because when I take the square root of x squared, I should get x. Okay, so I'm going to have 2 plus radical 5 times 2 plus radical 5. FOIL it, I'm going to get 4 plus 2 radical 5 plus 2 radical 5 plus 5. When I combine like terms, I'm going to get 9 plus 4 radical 5. On this next one, I'm going to distribute, so I get 5 radical 3 minus 54. So I can simplify this 54 into radical 9 and radical 6. So I'm going to move over here. So then I get 5 radical 3 minus 3 radical 6. I can't combine those because they aren't like radicals, so you're done. So in day 1, we looked at multiplying radical expressions. Now we're going to look at dividing them. And you're going to hear this term rationalizing the denominator. Because one of the rules that we said to make sure that a radical expression is simplified says that we can't have a radical in the denominator. Okay, we cannot have a radical in the denominator. So in order to get rid of them, we do something called rationalizing the denominator, which basically uses the concept that I told you kind of in the day 1 part, that if I take a radical, say I have radical 3, and I multiply it by the same square root, all that you'll have left is what's underneath. So it allows you to get rid of the radical sign and just have what's underneath. And the reason is because if I take radical 3 times radical 3, that becomes the square root of 9, which is 3. So we're going to use this technique to solve division problems now. Okay, so we have a quotient, radical 11 over radical 3. There's nothing we can do with the numbers. They can't be simplified. But one of our rules says that we cannot have a radical in the denominator. So to get rid of that 3 in the denominator, I'm going to multiply the bottom by radical 3. If I do that in the bottom, I also have to do it to the top. So now the bottom, when I take radical 3 times radical 3, just becomes a 3. When I do the top, I get radical 33. Now, can that 33 be simplified? No, so you're done. If that's too confusing, you can always write it as radical 33 over radical 9, which is equal to radical 33 over 3. So it's the same answer. I just kind of am showing you a little shortcut. So let's try these next two. Okay, so if I want to get rid of this 20 in the denominator, if you can simplify the fraction, do that first, but we can't. So I'm going to multiply the bottom by radical 20, and if I do it on the bottom, I have to do the top. When I multiply the top, it becomes 260m under the radical over, since it's 20 times 20 underneath with a radical sign, that simplifies to just a 20. Okay, what I want you to notice here is you cannot cancel the 20 with the 260 because the 260 is under a radical sign. So what we have to do is rewrite that 260 as a sum, as a perfect square. So I can rewrite that as 4 and 65 with the m staying there over 20. Now that 4 simplifies to 2. I can't do anything with the 65 or the m. However, lastly, you need to check if any of the numbers can be simplified. I can simplify this 2 with this 20, so my final answer becomes radical 65m over 10. And you're done. Okay, let's do one last example. So to get rid of this radical in the denominator, I'm going to multiply by a radical 12, do it on the top. So then I get radical 84a over 12. Again, you cannot simplify that 84 and that 12 because the top one is under a radical. However, if you think about it, the number 4 goes into 84 21 times. You need to keep that a. So now I get 2 radical 21a over 12, and the 2 and the 12 cancel. So my final answer is radical 21a over 6. And you're done.